Hi, I'm Mr. Raza and I'm going to be teaching you some maths. Today we'll be looking at recurring decimals and fractions. As a quick warm-up, we want you to just quickly use a calculator for the more complex fractions, convert these fractions into decimals. I'll just give you a few more seconds to tackle that and then we'll go through them together. So 1/4 we should know already as 0.25. 2/5 we should know as 0.4. 1/3, how many decimal places shall we write this to? We know that it's 0.333, as many threes as you can fit on your screen or paper, which of course can be expressed as 0.3 recurring. There should be a little dot above the 3 to indicate that the 3 is recurring. 3/10 is the equivalent of 0.3 without the recurring. 18/99. This is where we need our calculators. Our calculator display should be shown as 0.181818 recurring. Of course, it's the 1 and the 8 that's recurring, so we need a dot over both. Notice on the PowerPoint display that the dot is next to the 1 and the 8, but it should be high, and when you're handwriting, please put the dot above the 1 and the 8. 1/6, from memory or from the calculator, is 0.1 with as many 6s as you care to write, which of course indicates that the 6 is recurring, so we do not need the dot over the 1, whereas 0.16 recurring is the correct presentation. The objective of today's lesson is to go the other way round. We have recurring decimals and we need to express them as fractions. Once you get used to the procedure of recurring decimals being converted to fractions, you will be able to follow and understand the recurring decimal proof. All recurring decimals can be converted into fractions. To convert a recurring decimal to a fraction, introduce a variable, usually x. Form an equation by putting x equal to the recurring decimal. Multiply both sides of the equation by 10 if 1 digit recurs, by 100 if 2 digits recur, for example the 0.18 recurring, and by 1000 if 3 digits recur, and so on. With the 0.16 recurring, be careful, because although it's written to 2 decimal places, it's only the 1 digit that's of 6 that recurs. Then we're going to subtract the original equation from the new equation. So let's put this into practice. Of course, we'll rearrange to find x as a fraction. The example we're going to use is 0.29 recurring. We want to convert that into a fraction. We will label that decimal as x. Now, do we agree that 0.29 recurring is 0.292929, etc.? We can express it as so. Now, how many decimal digits are recurring? That's right, there are 2. So what should we multiply this decimal by? By 100. The whole equation will be multiplied by 100. The left side becomes 100x, and the right side, remembering how the decimal point moves 2 places to the right, becomes 29.292929 recurring. The next step would be to subtract the top equation from the bottom equation. The left hand side is easy. 100x take away 1x is simply 99x. The right side of the equation only works if you line up the 2 decimal numbers in tens of units format, remembering that each column must be directly beneath each other so that the decimal points align. Of course, if you start from the right hand side, 2 minus 2 is 0, 9 take 9 is 0, 2 take away 2 is 0, 9 take away 9 is 0, 2 take away 2 is 0, the points align, 9 take away nothing is 9, and 2 take away nothing is 2. So we should have that 99x is simply equal to 29. The last step is obvious. Rearranging this equation, putting the 99 on the other side, having x on its own, should give you x equals 29 over 99. Remember, if we are multiplying a number by x, to put it on the other side, you do the opposite, which is divide. You are dividing by the 99. X is simply 29 99ths. Let's look at a second example. It's written to 4 decimal places. 0.2371. The recurring decimal points are on the 3 and the 1. That means that everything between those decimal digits, including those 2 decimal digits, are recurring. The 371 recurs. So this decimal 0.2371 recurring simply means 0.2, 371, 371, 371, etc., etc. Now, how many digits are recurring? Be careful, it's not 4. That's right, it's 3. So what do we multiply both sides of the equation by this time? 3 decimal digits, 3 zeros, 1,000. The left side is simply 1000x. The right side is remembering where the decimal point moves. It moves 3 places to the right. So the decimal number on the right side of the equation is now 237.137.137.137.1. We need to subtract the x from the 1000x. And of course, the large decimal number will be the large decimal number taking away the small decimal number, making sure that everything is in alignment. The left hand side is simply 1000x take away 1x, 999x. The right hand side of the equation must show alignment in tens and units format. The decimal points are now in alignment. 1 take away 1 is nothing. 7 take away 7 is nothing. 3 take away 3 is nothing. 1 take away 2 is awkward. Of course, we need to exchange from the 7 to borrow across to make the 1 and 11. 11 take away 2 is 9. The decimal points are in alignment. The 7 became 6. 6 take away nothing is 6. 3 take away nothing is 3. And 2 take away nothing is 2. 999x equals 236.9. Remembering to rearrange the equation, dividing both sides by 999, x becomes 236.9 divided by 999. We have 3 marks of a 4-mark question. We need to remember that a decimal number must not be written in fraction format. What's the best way of getting rid of that decimal place? We should move it 1 place to the right. In other words, multiply the decimal number by 10. To keep the fraction equivalent, we'll multiply the denominator by 10 as well. So fraction x becomes 2,369 for the numerator and 9,990 for the denominator. In other words, the decimal 0.2371 recurring can be expressed as 2,369 9,990ths as a fraction.